Okay, so in this lesson, we're learning about composition of functions. This is lesson 4-6 out of your textbook. What we've done in the past is in 4-5, we learned how to add, subtract, multiply, and divide. So what we're doing today is like an extension of it. It doesn't mean it's any more difficult, though. So it's just kind of a different perspective. This is what your book says. It kind of draws you a picture right here. I actually preferred this one a little bit more. I found that one off the internet. So you don't have to write any of this stuff down. I just want to show you basically what you're going to be doing at the first part anyway. Okay. So let's say you've got a variable. I'm going to say X, and I'm going to tell you that I want you to plug in 10 for X. So you've got 10 here. What you're going to do, if you do a composition of function, is you're going to plug in that 10. That's called your input. So your input is 10, and when you plug it in, you wind up with a new number, and that new number is going to be 20, all right? Depends on the function and what you get. After you get that new number, you're going to take that output, and you're going to plug it into a different one, or maybe even the same function, and then you're going to get another output. So one more time. You're going to plug in at least twice. So let's say it gives you 7, and you plug in 7 into your first function, and you wind up with 10. That is your output of the first function. Your output becomes your new input. So you're going to take that 10, and you're going to plug it in, and you're going to wind up with a 5. Okay? So you're going to be substituting several times. All right, so this is what the notation actually looks like. So it's got like a little G on the outside. So if you've got a couple of highlighters, it might help you. So G's on the outside, but then you notice you've got F of 4 on the inside. Well, what that means is that F of 4 is going to be your input. So if I just told you to figure out what F of 4 is, y'all should be able to tell me that. All right, so what we're going to do is we're going to take that 4 and we're going to plug it into the f of x function. Notice that you have 2 functions up here. Make sure that you plug it into the right one. So I'm going to take this part right here, and instead of writing 2x, I'm going to leave that blank. I need to leave parentheses so I can substitute. So I'm going to plug in this 4 right here. And we are going to either use our brains or use our calculators, and we're going to simplify that. We get a 3. Now, I need you to listen very carefully. You see how I wrote that? I did it very specifically. So what you're doing is you're plugging in a 4. 4 is your input. After you plug it into the function, your output is 3. You need to start thinking of functions as an input and output relationship. So if I plug in a 4, I know it's going to be equal to 3. So guess what I'm going to do with that 3 right there? Yes, I'm going to actually take that and I'm going to replace f of 4. So now I just have g of 3 left. So that f of 4 is now replaced with the 3. So I'm on to step 2. I need to take g of 3, and I've got to figure out what that is. Okay, make sure that you're using the correct function. So instead of me writing x to the x squared minus 4, I'm going to put parentheses squared minus 4 because I'm substituting. So I'm going to replace the x with the 3. And then that means that g of 3 is equal to 5. All right, so when I put the 3 in there, I wind up with 5. So that means my final answer is going to be 5. And you just did your first composition of function. Okay, second example, what I'm going to do is I'm going to start on the inside. And that means I need to figure out what g of 2 is. We're going to plug in that 2 into the g of x function. So instead of me writing x squared minus 4, I'm going to leave a space to substitute there. And when I plug in a 2, I wind up with 0. Okay, and then that means that you can take that 0 and you can go back over here and replace g of 2 with 0. So now I have a new, it's kind of like the second step. So work inside out. So the second step is to find f of 0. So now your input is 0, and I got to figure out the output when I plug in 0 into the f function. So the f function is a square root function, and I'm going to leave parentheses where there's an x. So I'll plug in the 0. So f of 0 is going to wind up being equal to 1 when we simplify that. So final answer for the composition of functions is 1. All right, third example, what I'm going to do is start right here again. I'm going to find g of negative 2. All right, we're going to plug negative 2 into the g function. The g function is x squared minus 4. So I'm going to leave parentheses, squared minus 4, plug in the negative 2. And that's what? 4 minus 4 gives you 0. So that's only your first step. So your input was negative 2, output was 0. Now I'm going to take that output and I'm going to plug it back in. And I'm going to use the same function because it says to use g twice. So I'm going to plug in a 0. So 0 equals 0 squared minus 4. So g of 0 is equal to negative 4. So final answer will be negative 4 for your composition. Now that you understand the input and output, you don't have to always substitute. You might have a question that looks like this. They give you enough information. As long as you understand the input versus output relationship, you should be able to do this. No calculator needed. No calculations needed. So pause the video. Let's see if you can figure out what the final answer is, and then we'll talk about it. All right, so what we're going to do is we're going to look at F2. Remember, like if they gave you like the functions, you would plug in a 2. But look at what they gave you. Look, it says f of 2 is equal to negative 3. So instead of making you plug anything in, it just tells you what the result is. So you're going to replace f of 2 with negative 3. Y'all see that? Okay, now that is just asking you to find g of negative 3. Does it tell you what g of negative 3 is? G of negative 3 is 10. Yeah. So it gives you, instead of giving you formulas or functions that you have to substitute, it actually tells you the input and the output. It can also possibly give you table form. X would be your input, Y would be your output. So you can actually track a table and figure out compositions like that as well. Okay, so on the back, what we're going to do is we've got 3 different functions. Take about a minute per and see if you can figure out each composition. Stop the video and then hit play when you're ready to check your answers. Okay, so this is what your 3 answers should be. Just remember this first one, plug in negative 1 into G, and then that result is going to plug into the F. Second one, plug in negative 7 into the H function, and that result would be plugged into the G function. And then C, you just take the 0, plug it in, and then you plug in negative 2. Okay, so let's move on to the more difficult section. We're going to do composition of functions, and I want you right now to write no Desmos. It's not that I don't want you to use Desmos. It just means that you can't. Like, you just literally cannot use Desmos to do this problem for you. And the reason why is because look at your input. Your input is a variable. It will not evaluate variables for you. So I'm going to show you a shortcut way to do it. Okay. You're going to highlight this part like you did before. But the only difference is you cannot plug in a number. Like, you don't have that option. So you're going to take and you're going to substitute g of x. And that's weird. You're going to have to substitute g of x. So you're going to substitute that right there into f of x. You're going to have to substitute g of x into this f function right here. So the easiest, quickest way to do it is you're going to just put an F and then you're going to make big parentheses because it's got to be big because you're not just plugging in a number. You're going to plug in the function. So the G function is 2x plus 5. What you're going to do here, so your F function is x squared plus 7, correct? you have to substitute 2x plus 5 into that x. So don't write x squared plus 7. Don't do this either. Don't do this. Do you have room to substitute 2x plus 5 into that? Absolutely not. So you're going to make big parentheses. So big parentheses squared plus 7. So whenever you're substituting a function, make really big space in your parentheses. We're going to take that 2x plus 5 and we're going to put it right here. That's the hard part. So you're going to take the existing f function and you're going to replace the 2x plus 5 in there. All you have to do now is simplify. Simplify. We're going to do some basic algebra 1. So you're going to multiply 2x plus 5 times itself. So 2x plus 5 times 2x plus 5. So just use your box method, multiply it out. Okay, so I did the box thing, and remember in your box, your diagonal has to add together. So I get 4x squared plus 20x plus 25. Now there is something that I am forgetting to write down. What is it? What have I not done? Yes, a lot of people forget the rest of the function. So after you multiply the 2x plus 5, write that down, and then you still have to add the 7. So 25 plus 7 is going to give you 32. All right, the second example tells you that you're going to have to take f of x and you're going to have to plug it into the g function. So I would just very quickly put f of x right here. What is f of x? F of x is x squared plus 7. Okay, I'm going to take that x squared plus 7 and I'm going to plug it in to the g function. The g function is 2x plus 5. So you have to use big parentheses for the x. And you're going to plug in x squared plus 7. So what is here has to go in for your x on that side. You are substituting x squared plus 7 into the other function. All right, so on this one, all you have to do is distribute. So you get 2x squared plus 14 plus 5. And then you can add the 14 and the 5 here. So that'd be 2x squared plus 19. Okay, last one real quickly. Okay, f of x. You have to take f of x and you have to substitute into f of x. You're taking f of x and substituting into itself. How do I know that? Because it literally says f of x. So what is f of x? That is x squared plus 7. So I'm going to put x squared plus 7. That's what I substituted last time. The only difference is I'm substituting it back into f of x. So f of x is x squared plus 7. So I'm going to put big parentheses for the x, squared plus 7. This is f of x. I'm going to replace that over here. So what I have in this input has to be for the x's over here. Okay, kind of running out of time, but you got to do the box method. And when you do the box method, you get x to the 4th plus 14x squared plus 56. Drop the 7 and then add those two together. And final answer is, oops, sorry, that should be 49. My bad. That should be 56 total answer. Okay, let's go ahead and finish it up. We're going to do the domain of the composition of functions. Now, what this is basically saying is we're going to take the input. So the input is basically what is on the inside of your composition. You need to consider the domain of the input. So that's the first thing that we do. What is the domain of the input? Then what you have to do is you've got to figure out the domain of your composition. So you're going to have to either find the composition. If you've already done it, it's super easy. And you have to consider the domain of the composition. Your final answer is going to be what is in common with these two domains. So in section 4.5, it's different. In section 4.5, you have to consider individual domains. So you look at f of x, you look at g of x, and you figure out what's in common. These two are different. So you have to look at the domain of your input, in this case would be g of x, and then you have to finish this right here and then find the domain. So let's use these f of x and g of x that we already have. So I found that f of g of x in this case was 4x squared plus 20x plus 32. Now let's go back and look at our input. G of x was 2x plus 5. So let's look at their domains individually. So this one would be all real because it is linear. And this is quadratic. It's also going to be all real. So if you're going to figure out what's in common between all real, it's going to also be all real. So the domain of f of g of x is going to be all real numbers. Okay, let's look at one that has something that has a limited domain. So I'm going to give you a new f of x and g of x. So this g of x is limited because that is a square root function. This one is not limited. It's going to be all reals. So let's take, for instance, f of g of x. So same basic composition, but just different functions. What I have to do is I have to consider the input. This is your input. So the domain is going to be x is greater than or equal to 6. I know that because this has been shifted to the right 6 places. So this is the domain of my first function. Now I have to figure out the composition of the two. So I'm going to plug in the square root of x minus 6 into 4x plus 2. Okay, simplify. There's not much to do here. So this is actually the result of the composition of the functions. And if you look at that, I have the exact same domain. It's been shifted to the right 6. So this one also has a domain. And if you look at both of them together, they're exactly the same. So your shared domain for that composition would be x greater than or equal to 6.